I know security people don't like raising their hands, so this means yes and this means no. How many of you have ever dealt with are familiar with serverless technology at all? Okay, awesome. So we'll do a brief overview. Jules will do a brief overview of what serverless is, and then we'll dive into this security tool that we've created. But first, I'm Justin Massey.
And I'm Jules.
And we're both security engineers at Datadog. The tooling we're about to talk about is an internal tool we use. It was developed by us. It's not a security product that you can come and buy from us. So this is not a sales pitch or whatever. We were talking to some people yesterday or today, and they're like, is this a security product that you sell? And the answer is no. So we are going to give you a framework that you can use in your own business. So with that, we both work on the security product team, and our goal is to secure all the things. As you would imagine, we constantly have products that we're releasing, and our job is to make sure that the products go without vulnerabilities into the code base. So our goal of this framework is to allow the developer to own the security of their application. We work in a DevOps shop, and the developers own the uptime of their application. So if an application goes down, they're not calling the ops team. They're the on-call people. So they have to make their application work. And we also want to give them the ability to also own their security of their application in the same way that they own the uptime of their application. So to do that, this is a very common principle in all security: find bugs early, fix bugs early. But this is even more important if the developers are owning the security of their application, because we want them to have the code fresh on their mind. So if they just added a vulnerability into the code base and we're able to tell them within a matter of minutes or an hour, that code is fresh on their mind, and they don't have to go through this process of like, how does this code work and whatever process. So that is the goal of this.
So obviously, there's a lot of security tools out there already available to tell you whenever there's a vulnerability in your code, or at least help you finding those. And if you're familiar with developers' environments, obviously CI/CD is a very commonly used environment for developers to test and ship their code several times a day. But somehow we felt like those two elements have had some kind of love-hate relationship so far. So what do we mean with that? Security tools often don't integrate well with CI/CD because first, they have long-running jobs. It's really not surprising to see a security tool having a scan of like a half an hour, 5 hours, or even more. And in a CI, you really want your test to be fast. If your test is taking more than a few minutes, your developers are going to be angry. So obviously, it doesn't integrate well. You have a lot of false positives, and you don't want your test to be flaky. So that doesn't work well as well. And each tool has its own way of giving a report. So it makes it very confusing for developers to understand the outputs of every security tool and what's going on and what do they need to do, because they are not security experts, and they are not experts on every tool we use. So an example of such a tool, and that we're going to try to improve today, is checkmarks. Checkmarks is a static analysis tool, and jobs on checkmarks and scans can take a long time. So it doesn't integrate well with CI/CD. On the other hand, sometimes you have security tools that integrate well with CI/CD, but we felt like they don't integrate well with developers' workflows, and that's an issue. An example is that those tools will block the deployment pipeline whenever they find something, and we all know that security vulnerabilities have different severities, and depending on your business, you might have a vulnerability management program, and a low severity issue doesn't need to be fixed right away. Eventually, you'll fix it within the weeks or the 2 weeks. And you don't want to block every pipeline and every deployment for a low severity issue. And otherwise, they also report their results in a third-party website, and that's also a problem with developers' workflow, because you don't want the developers to click on the website every time, on a different website, on 1,000 websites for each tool, to see what the problems are, and it doesn't integrate well within their workflows. An example of such a tool is Snyk. Snyk is a third-party dependencies vulnerability tool that will actually try to find known vulnerabilities in the libraries you use, and integrates well with CI/CD, but at least where we work, we thought that it didn't integrate well with developers' workflow for those reasons.
So I was working on the checkmarks project, and Jules was working on the SNCC project, and we were trying to solve the same solution, or we were trying to come up with a similar solution. So we didn't want to recreate it twice. So we wanted to create a plugin-based workflow so that whenever we have any other security tooling we want to add in, we can easily add it to this workflow. We don't want to have to recreate it. So the first step in the workflow we saw in the commonality was a trigger. The trigger is something like a GitHub pull request. A developer makes a pull request, and now this is about to go into production. So we want to scan this code. So we can subscribe to GitHub webhooks. We can do other things. You could also have a trigger that is something like a Slack message. So I want to scan this repository, so a developer can just trigger the workflow with a Slack message. So each of these are, we'll go in more detail about serverless and lambdas and how they work, but each of these we wanted also for them to be able to be developed in whatever language you wish. So if you want to develop in Python or Go, you can write in that. So the next step is the processor. So this is where the bulk of the action happens. So in our previous examples, we had checkmarks and SNCC. This is where they would go. So this is where you've taken the trigger, which we'll take for the example, the GitHub pull request, and it will then, the processor will take that branch and will clone it down, and it will do the analysis on the difference in that pull request. So once that tooling has completed, it will then need to give that output of the tooling somewhere. So this could be in the same GitHub pull request. We could have that actual tool write a comment on the pull request and say, hey, congratulations, 0 vulnerabilities found. Or you could say, hey, we found this one vulnerability in this line of code. So, or this could be a Slack output. So it could send a Slack message to a developer and say, hey, you just committed 20,000 vulnerabilities in this, go fix it. So this is, reiterate, very modular. Each of these can be written in any language and can be reused. So our first solution to this was the GitHub pull request, which would make an API call. So we'd subscribe to the GitHub events, such as a pull request or a push event. And it would submit the webhook to an API gateway, which is an AWS service. And then the AWS service would fire a Lambda function. The Lambda function would do 2 things. It would, 1, do the security scan, which would be that middle processing layer, and it would give the output to the PR commenter. So this was our very first solution and what we were going to run with. However, we had some issues. Checkmarks can take 5 hours. That's for just under 700,000 lines of code. Lambdas typically can time out after 300 seconds, which AWS has increased since we wrote this presentation, and it's now at like 15 minutes. So clearly, we cannot have that Lambda function running and waiting on that scan for 5 hours if it's going to take longer than the timeout period. So we had to fix that issue. Next is the notification process. So checkmarks, in order to get the results back, you would have to go to their website, and they don't really give you any good way to push to comment on a pull request. So we had to solve that solution as well.
So having those problems in mind, we still wanted to use AWS Lambdas for several reasons. The first one is that it makes it very easy to implement in different languages, as we said, Python, Go, Node.js, and for all the developers out there, since yesterday, they announced COBOL. That's not for us. So it makes it really easy to have all the different elements independent in different languages, and everyone can code anything. The second thing is that it easily scales to a reasonable amount. What I mean by a reasonable amount is that if we have 10 PRs a day today, or 10 PRs an hour, we can go to 100, eventually 1,000, but we're not talking to 1,000,000. So to a reasonable amount. And our goal is not to re-implement this system every 2 months or 6 months because our company grew too much. So Lambdas were great. They easily scale. They are independent. You can code them in whatever language you want. So there were our choice. So since day timeout, we had to come up with some kind of a workflow solution. So we started drawing ideas on the board, kind of complex. The goal is to share a state between the lambdas to make them work together. If we clean it a bit, this is how it looked. This is our first design, where every lambda will start its execution receiving a workflow ID, retrieve the state in a DynamoDB with all the variables that are needed for the workflow, then do its processing, do what it needs to do, and once it's done, it will save the workflow state in DynamoDB and trigger the next Lambda. And doing so allowed us to have some kind of like workflow with Lambdas, retries, and stuff like that. Obviously, it was lacking some features, but the first POC worked very well. But in the end, we just realized that we kind of recreated AWS step functions. And so I'm going to talk a bit about AWS step function and how it works. AWS step function is a state machine. It's a workflow. So you define a workflow where each step with the Amazon state language, and each step is a state. And you have the step function console in AWS that kind of works like a GUI, where you can see every step, which path was taken, which step failed, what are the input and output of each step, and how it works. So what are the different states we can have? The first state, and the most important one is the task. That's actual code you're going to run. It can be an activity or a Lambda. We're going to use Lambdas here. So it's just triggering the Lambda, waiting for it to finish, and triggering next step. The choice we'll decide easily between two or different steps which one to run depending on the variable in the state. Pass is exactly like in development. It does nothing, but you can still modify the actual state variables and modify the data you pass around. Delay allows you to wait without paying. That's pretty cool. So if you know some scan is going to take an hour, just put a 1 hour delay and then it will trigger the next step without you paying for that amount of time. Parallel is very interesting if you have several scans because they can run independently in parallel. And so if you have 10 scans, you have all of them running at the same time. And once again, independently, you don't have any performance issues or whatever because those are different containers. And then success or failure just gives information to the workflow. Hey, did I succeed or did I fail? That's what you will see in the GUI. So here's a very simple example of a state machine, start and end of the state machine, and every block in the middle is a state, individual state. So here we get a JSON in input. GitHub trigger will parse some of the data, get what it needs, and the Slack sender role is just to send a message on Slack. And so it's a really easy workflow. Now, the one we're going to talk about today to solve a problem looks like that, and it's quite more complex. But before diving into the details of what every step does and how it works, we're going to do a demo.
So as Jules sets us up, what you're going to see at the very top is the AWS console, and each of these below name you see a UUID4 value, and that each of those represents a state machine that has been ran, and below that you'll see a terminal. And this is a developer has already put in here git push origin head, so they're pushing their changes to GitHub, and yeah, so you're looking at that.
So if I start, we can see in the bottom now the PR and it has been pushed to the repository very quickly. The pipeline is running now. The workflow is running. We can see in the GUI here easily which step was taken. So checkmarks won't run because it was just a dependency change. And we can see on the right, it's not very clear, so there's a blue block. Blue means it's running, so the sneak scan is running right now. We're going to zoom a bit. It really is convenient to see which path was taken, and we can see everything, that every input and output. The PR commenter is running right now. And once it's done, so right now we're switching to the GitHub PR. So this is the GitHub PR that I made with my change, and I can see the outputs of the tool. So here I can see the name of the dependency, the actual version, the severity, so that the developer can eventually prioritize, oh, is that a low issue or a high issue? Do I need to fix it now, or can I fix it tomorrow? And the affected version, so I know what I need to do right away. So let's dive into the details. And the first part of the workflow is a GitHub authorizer and a choice. And it doesn't quite look like the trigger we talked about before. And that's the reason of the first problem we hit when we started doing this, is that GitHub and AWS are incompatible by default. What we mean with that is when you subscribe to a webhook from GitHub and you want to make sure that this event and this payload really comes from GitHub, you give them a secret and they will compute HMAC signature of the payload they send you. It's using SHA-1, but it's fine because the whole environment of GitHub is relying on SHA-1. So obviously we know that SHA-1 had issues, but since Git is working on SHA-1, they can rely on SHA-1. That's their threat model. I'm not going to discuss that. So they compute a signature that they put in the header, and so once you receive the request, you recompute the same signature, and you check that those two are the same. The problem is that when you look at AWS API Gateway Authorizer, API Gateway is what receives the webhook in AWS, you have two kinds of authorizer. The first one is a token, and it gives you everything that is passed in the header. Here it will be only the signature, so you can't compute since you don't have the payload. It works very well for API tokens or BIRA token, where you can all at once verify the integrity and that it really comes from a trusted device. The second type is a request type, and even though the name sounds great, it gives you a lot of things, but everything but the payload. So API Gateway and GitHub are kind of incompatible by default. So our solution is easy. We just put the authorizer as the first step of the step function. You just need to not forget about it. So it was quite painful, but the code in the end is pretty easy. You just generate the HMAC signature, and then you take the headers. You just compare time constant comparison if you care about side channel attacks, and then you can easily say yes or no. This is a true event or not. So now that this first step is over, we're really starting our process and the trigger part. So the GitHub trigger from the JSON gets all the data it needs. What is the name of the branch? What is the repository? Which username sent the change? What files change and stuff? Everything you need or that the scanner will need to run. The second part is a sanitizer. So AWS step function have a workflow state where all the data you use is passed through every step. The problem is that the size of this workflow of this state is limited. So it's kind of like a go back to the old times where you had a very limited amount of memory. This step is just removing all the unnecessary data so that the scanners later on can use it to show their to list the vulnerabilities they use. So it's a sanitizer. You're freeing memory. And the last part of the trigger is now that I know what files were changed, what happened, I can decide which scan to run. So in the example we showed in a demo, I only changed a requirements file, so only dependencies. There's no reason to run static analysis on that. I'm just running the dependency check. So that's the first part. The trigger is done. I know which scan to run. And I enter the split part we can see on top right. And there's one branch per scan. So the first scan, here I have just a choice. Did the scan filter decide to run this scan or not? If the scan shouldn't run, I just go to a success step and I stop there. Otherwise, I run the scan. So now the scan runs. I have my Lambda querying what it needs and the API of Snyk to know what happened. And if it all went well, I'm going to the PR commenter that will give the output on the PR. And we'll dive a bit more later on why we decided a comment on the PR. The last step, which is eventually strange, it's an error handler as a state itself instead of in the code, and it's a catch-all. So the thing is that when you have branches on AWS step function, if any of the branch fails for whatever reason, and this reason is usually an exception because something broke, it stops every single branch. So you obviously want to put a catch-all and monitor that. So you put a log line saying, hey, we got an issue there. but I'm not blocking, because if you have 10 scans and for whatever reason one is failing, you don't want all of them to fail. You don't want to fail open. That's kind of the same with scanners. So we put this catch-all to avoid that. Now, this is how a simple scan should look. We had the trigger before. We have one step for the scan, one step for the output, but sometimes it is not that easy.
Introducing check marks. So the first step, as Jules mentioned earlier, is the scan filter. We saw earlier that the scans can take somewhere in 5+ hours for 600, 700,000 lines of Python code. So in the scan filter step that was prior to this, we were able to say, we were able to do some logic on that pull request. So we get the difference of that PR and say, okay, maybe check marks we only want to scan for a certain language. Maybe if you modify a JavaScript file and you only really want to scan your Python files, well, let's not create a scan on that because that's a static JS file. We only want to scan like Python, or you want to scan maybe you only want to scan like if the authentication file changed. You can do all of that in the scan filter. So what we can do here is we can either filter out, or if we do want to create the scan, we start here. And what this does is we create an incremental scan because incremental should be faster than full scans. So we will create the scan, and then the checkmarks server. So checkmarks is running on an EC2 server. Checkmarks is not running in the Lambda itself. So it's making a REST API call to the checkmark server and says, hey, create the scan. Checkmarks will then respond and say, okay, I've queued your scan. Here's your scan ID. Check back later. So that's exactly what we do. We say, hey, checkmarks, are you done yet? The answer is probably no. So then we use that delay that we mentioned earlier, and we delay this Lambda function from running again and for another 2 minutes, 5 minutes, and then we'll go back and say, hey, checkmarks, are you done with the scan? And once the answer is yes, I'm done with this scan, it goes to this scan choice. So checkmarks, by default, if the code base changes larger than 6% and you have scheduled an incremental scan, it will say, no, you need to go run a full scan because there's been too much change in the code. So then what this scan choice will do is it'll go back and create a full scan. And then if the answer is, I was able to successfully create the scan or complete the scan, it then returns the report ID, which then goes to report. And once again, checkmarks is probably not done with the report yet. So we create a delay on this, and then after a couple minutes, we'll then check back and get the report. And then after that, we make the PR commenter. One thing we actually do in this step right here as well is sometimes when there are changes made in the code and checkmarks finds vulnerabilities, it may find vulnerabilities that are not related to that pull request, to the change in that from the head to the master branch. So what we do here is we make sure that whatever the developer changed, or whatever vulnerabilities were identified, were actually changed in that pull request. Because what we don't want are false positives in the developer workflow. So if the developer made a change to the authentication file, and there was another vulnerability identified in another part of the application, we may want to deal with that out of band. But if the change was made in the authentication file, then we will want to comment on the pull request. So that's a way that we deal with false positives and ensuring that the developer is only getting what is relative to their code. Now we have the catch-all error handler. And you can see here that we have a couple more things pointing to the checkmarks error handler due to the fact that we have a little more things going on. So an issue with dealing with errors, there are a lot of logs. Each one of those steps that we had in is its own Lambda function. And if you were to look at the Lambda function, if you were to click on, this is, you can see the same workflow. This is, if you were to click on this in the Amazon console, the very top one below start is the GitHub authorizer. If you click on that, you see this. This says status exceeded and the resource. This resource is the Lambda function itself. Each of these steps is a different Lambda function. So all of the Lambda functions go to separate CloudWatch logs. So if you want to follow it through from step A to step Z, you have to go into each Lambda function's cloud logs, and it's very difficult to trace through. So what we wanted to do was grab an identifier to pass through each of these state machines and log it, so that we could trace it through each one. Well, so if you dealt with lambdas, you know you are given two pieces of information in every lambda that's sent to the handler. You have the event and you have the context. So in Python, we dump the vulnerabilities. Unfortunately, that unique identifier just doesn't exist. This made it very difficult to trace from step A to step Z, so we had to come up with a different solution. So our solution to that was to create a unique ID on the very first step. So that's in this example is called state ID. So we take that state ID and we create a custom context filter, which is a superclass or a subclass of the logging filter, default logging filter, and we add in a state ID. And we also add in a stage, and the stage can be used. We use it internally. We have a stage. We have a prod and a develop environment for using this. So it'll let us know whether we're looking in prod or staging. So we add those two variables, and then if you're familiar with Python, you can create the custom log, or you have the log formatter here, and what that specific context filter did is it adds the ability to add in these variables. So we create the logging, we create the logger, add the stream handler, and add that custom log formatter in, and then we give that to every single application. So this is Datadog log product. You could use any log product you want. But you can see here all the different log lines versus having to deal with them in AWS himself, because once again, you have to filter, you have to click on each individual CloudWatch log, which doesn't make it very easy. So we aggregate all them in here, and if we zoom in, so at the very, very top, there's the state ID, so we're filtering based on a specific state execution. If we zoom in, we will see dash prod dash in this state ID. So what this does is we can see at the very top, that's the PR commenter, that's the last step. Then you can see below that, you can see that checkmarks is running. Those are two different states, or sorry, two different steps. So we can very easily trace things going on, which makes it a lot easier to debug the issues.
So after all of that, having the logs allows us to make sure the system works correctly, or at least when it doesn't, we know how to fix it. We have a reliable way of scanning our developers' code. They make a PR, we get the scans running right away, we get the vulnerabilities. The last problem we had to deal with is, how do I tell my developers what the issues are and what is the best way to do so? So we have to really take into account that the developer is a very important part of the project. Their engagement is crucial. As we said in the beginning, we want the developer to own the security of the app. We want them to fix the issues because they know the code better than we do. So we obviously want them to feel engaged, and we need to give them the results the way they want. So in the best way possible for the developers, that's how we want to give them the results. Overall, we want to be as low friction as we can be, meaning that if we add any pain points during their workflow or their work, they won't want to help us. So we want to be low noise, no false positives, easy to read, where they don't have to go through a huge report of 40 pages to see one vulnerability. They maybe don't need to know how to exploit it. We also want to show them where they are working. We don't want them to click every time on many websites to have the different results. We also want to make the issues found actionable. If I'm getting a vulnerability, it can happen on libraries, and the library didn't get patched yet, there is no remediation possible, it's not worth it to tell the developer right now. It's obviously worth it for us to log it and be alerted as a security team, but it's not worth it to tell the developer, hey, there's a vulnerability here, and you can do nothing about it. This is not this is not worth it. So we want to make the issues found actionable. And in the end, it might sound strange, but we want the developer to be kind of like our customer. If you're running a business, you want your customer to be happy. If you're running a security team, you want the developer to be happy, and then work together towards those security issues. So how do you do? How do you know how to surface those issues? There's several ways we present. The first one is to send an email, an organization-wide email asking for feedback. And it might sound crazy. If you have 300 engineers, you might only receive 3-4 answers, but that already helps a lot. It's a lot because those people will raise you their concerns, how they want to see the issues, and they can help you find the first way. It already helps a lot. The other idea we started is having an application security focus group. So you gather a few people for a meeting, not too often because otherwise it's annoying. But sometimes you just explain what you do, you listen to them also, you listen to what their pain points are. You can also eventually attend, if you have any developer efficiency or developer happiness focus group where people explain what their pain points are during their development workflow. It's very interesting to attend those to understand what they're facing every day. And while explaining what you do and why you do it, you can also ask them how they want the issues to be surfaced. They'll understand why you do it if you explain it well, and they'll try to help you find the best way. And also, direct discussion with developers are very, very useful. After a coffee, after lunch, beers after hours, anything. It's very convenient to talk in person to the developers, explain them what you do, tell them that you're not a jerk, and try to understand why their day sometimes is so bad. And doing so also allows you to have them beta test your solution. If you didn't find the right way to surface the issues, you don't want to deploy your solution everywhere and have every developer being mad. You can have some of them, developers you know, be your beta tester, and they'll let you know if there's an issue. So here, for example, we did a simple feature flag based on the branch name. So if the branch name starts with my name, then I will run the PR commenter, otherwise I don't. And so doing so allows me to allow a few of the developers to beta test, and when they receive a message, they'll tell me like, hey, Jules, I don't understand this output, it doesn't make sense, or I cannot do anything about it, and then we can improve our product before doing a global deploy. So another thing which is important to keep in mind to make sure that you integrate well is you should try, and we try as much as we can, to follow the developers' workflows. And trying to use the same CI/CD tools. If they're using GitLab to run tests, try to use GitLab to run tests. If they're using Jenkins to deploy, try to do the same. It will help you understand what are the pain process during the CI/CD and the developer workflow. And so you make sure you're not adding a new one on top of that. Try to use the same technologies. If they're doing Python and Go, that's the case mostly at Datadog, try to use Python and Go. This way, you can understand what are the problems of their environment. If you're dealing with JavaScript and you do not understand what they're facing when they're talking about their Go pipeline issues, it might be inconvenient to then integrate. Overall, doing so will help you understanding their constraints and better integrate. So what is our solution? Our current solution, as we showed in the demo, is a comment on the PR. Why? First, because we think that this is where the developer is. We use GitHub at Datadog, and everybody will put a pull request before sending to prod, wait for a peer developer review. So this is a place where we can easily surface the issues. And even if they have to merge really quickly because there's an outage or a problem, and our scan is taking a lot of time, we can have a comment coming after the merge, and they will still be aware through an email or normal notifications. So also, we're showing only what's necessary for them. So here, for example, we're showing the dependency name, actual version, severity with the link. Many developers are very curious about security issues, and they want to know more. So we don't think it's mandatory for them to know what's going on, but give them a link if they want to know more. And then the affected version. So here, for example, I know very easily that cryptography needs to be upgraded to version 2.3. What is our plan for the future? As you can see, we had in every scan a PR commenter doing a different comment because we wanted the results to come as fast as possible. We want to try to make them all in a single comment, which we think is better. Try not to flood the PRs with thousands of comments. Also, auto-fix PR. There's many things that can be automated. I'm not saying auto-fix to prod, I'm talking about the PR. So a dependency change, for example, here we can see that cryptography needs to be upgraded to version 2.3. It's fairly easy to change the requirements.txt file, commit that automatically, and push it to as a PR, as a pull request. And then if you link it to the developer, they can already see the CI that run on the pull request, see if it failed and why, see if it passed, and if it's fine to merge right now or not. It may save maybe 30 minutes to the developer, but it adds up very quickly and it's very convenient for them. So those are our ideas of improvement for the future.
As we mentioned earlier, this is a framework that we want you to be able to take home and implement in your company. So in order to deploy this, you need a couple things. You may not have check marks, so we're going to give you a different example. You'll need the GitHub authorizer because you'll need a way to validate that when a API call comes in from, or when a GitHub event comes in to your API gateway, you're going to need an authorizer. So we'll have to have that. We'll need to have the trigger, which is can extract the information like the pull request number, the user, and all that, so that you'll need the trigger. This example. You'll need a plugin that uses the Go security scanner, formerly known as GAS. That's an open source one that runs pretty quickly. And then you would have a GitHub PR commenter, and that would write the comment on the pull request. And then you could also have a Slack commenter. So you can, all that saying that we talked a lot, but this is not that, these things are not that difficult. Most of these are available online. You can find them in Go or Python or whatever your language is and write them to use with the serverless technology. In order to deploy them, so this is the way we do it at our company. It's you can do it many different ways, but we can deploy the Lambda functions with serverless framework. And then we deploy the rest of them, like the IAM roles. We have to have IAM roles to log to things like CloudWatch, or for the Lambdas to talk to the EC2 instances if they need certain things. And then the step functions. So this is the step functions ties all the Lambda functions together. We use Terraform for that, and also to deploy the API gateway. So with that. We are done, and we are happy to answer any questions you may have. And shameless plug, we are hiring if you're interested.
Okay. There's around 10 minutes of questions available to us. Anyone taking up the opportunity?
Any questions on... We're happy to answer any questions serverless related, Lambdas, any other issues.
Okay. I especially like the aspect that you really put a lot of thought into getting the user interface right, and especially thinking about who's using our application and our service. So I think that's very important, and often missed in security tools especially. They're functional, but they're not really friendly to use. So I think that's a very good approach you've put into that. I like that a lot. How's the response of your developers? So how do they react to being confronted with, oh, here's a lot of information?
The response was mostly good, I think, at first. Also because I asked all of my friends at the company to beta test it, and maybe they didn't want to say bad things about what I was working on, but they all understand why we do that, and it's very hard. They all know that we are at risk, like any company, and they appreciated the fact that we really try to be as less friction as we can be, low friction as we can be. What you just said, they really appreciate the fact that we put a lot of effort into surfacing it well. And I think it has been even more since we've had, security is a support team, and there's a lot of support teams like infrastructure team, and we've seen mistakes on those ends, and they're really happy that we didn't do the same mistakes. Worked very well. We had few very good issues surfaced that got fixed really quickly. So overall, very good. Now we don't have it hasn't been running for many months, so we're still waiting on more real feedback.
There's one other thing that we didn't really mention in this talk, the difference in between the scan engine, so checkmarks and SNCC. The way vulnerabilities, a developer may introduce a new dependency, and that dependency may be vulnerable. So that's one case for SNCC. Another case is that a library has now become vulnerable, but it's been existent in our application for a long time. So if you have a developer that we run this scan, and this is the first time the scan has been run since this vulnerability has been found and has been identified, that's different than a developer that just introduced the dependency. So those two cases need to be handled very differently. You may have to open an investigation to see if that dependency that has been found vulnerable, that's been in your code for a long time, actually affects your application, versus the developer that's now introducing a new dependency that is previously vulnerable. Something like what's the PyCrypto library that we commonly say don't use. Use cryptography or whatever. So if someone introduces a new dependency that's vulnerable, we can immediately say, no, let's not release that. Whereas if it's been in our code for a long time, we're not going to halt the build pipeline right then, because it's been in our product for years and someone has just now found a vulnerability for it. So those two need to be handled differently.
Any further questions? No? Well then, thank you very much,
Thank
Jules
you.
and Justin.